Good morning, everyone. My name is Arthur Guichet, Secretary General from the European Water Association, and welcome to today's webinar on water management, quantity versus quality in sponge cities. As you know, this webinar is sponsored by ACO. ACO is one of the world leading water technology companies specializing in stormwater and wastewater management. Their motto is ACO, we care for water. Care in the sense means being both protective and attentive, and this philosophy is deeply indeed in the ACO water cycle, which encompasses the collection, transportation, purification, storage, and reuse of this vital resource. And through innovative separation and filtration technology, ACO prevents water contamination from fats, fuels, heavy metals, and microplastic. And today's ACO operates in over 50 countries, ensuring proximity to regional market and strong business partnerships. So thank you very much for this partnership today and today's event. It's also allowing us to have it for free. And I will tell you what's, about today's. We'll have two keynotes. So we have Alberto Pistocchi from GRC, the European Commission, Anna Friedrichs von Berliner Regenwasseragentur, and Moritz Gersterding from ACO Beton. Before we start with all the presentation, you will have few words about the European Water Association. I will also explain you the house rule for today's and how we are going to operate. So the European Water Association, we are an independent, non-governmental and non-profit organization dealing with the management and improvement of the water environment. We have members from nearly all European countries. We have three categories of members. We have national members representing water operators, setting up technical requirements for them, and so on. We have corporate members, and we also have research members. And this, let's say, broad variety of water actors, all members of EWA, leads to all of them talking together, and we therefore see us as a forum for discussion on key technical and policy issues in Europe around the water sectors. And we also aim to spread the word around water, to also explain some EU regulation around water to a broader audience. And in order to do so, we arrange conferences, workshops, meetings, internal special working group of experts, and also via publication, media, and as well as events such as today. So about today's, it's a webinar. Please note that the three speakers had agreed that the webinar is recorded, will be posted on YouTube EWA channel after it. You will also receive all the presentation, and you cannot use the raise hand function as you are all muted. So please either use the chat box and or the Q&A box if you have any questions or comments. Yeah, so that's it from my side. Sorry. Nope. I will stop sharing. And today's first keynote will be Alberto Pistocchi from the Joint Research Center of the European Commission. Alberto, you hold a PhD and you have been working as a civil environmental engineer and land planner in the past 30 years. You are now working as a scientific project officer at the European Commission GRC over the past 12 years. You have developed quantitative policy analysis in the field of integrated water resources management, river basin management, and the water food energy ecosystem nexus. You are currently research and policy support work relates to water reuse, urban water management, water resilience, and climate adaptation. And your presentation will be on the Urban Wastewater Treatment Directive recast and stormwater overflow requirements. Alberto, thank you for joining us. The floor is yours.
Thank you, Arthur. I'm sharing the presentation now. Good morning, everyone. I'm going to provide you an overview of the provisions that are introduced with a new directive that has entered into force basically now. and some considerations on the background that has led to this legal development.
Alberto,
Pollution
I still see it into the PowerPoint itself, not on full screen for your
is that
presentation.
working like this?
I still see it open it into the app, but not on full screen. Or is it just me? Okay,
It's the
click
same
again to
for
my. Okay, I think
So
yeah. Click from the beginning again to start the presentation mode. Yeah.
is that
No.
working?
No. Same.
Murphy's law. We
Yeah.
just tried, but it doesn't work anymore.
Yeah.
So let me see. I stop sharing and
Yeah.
share again.
Yeah. Please.
Um, uh, that should be. Can you see it now?
Now it's still, yeah, what's it from the beginning just to see? No, it just does not switch into full screen mode.
maybe
So
press
you still see it.
F5.
Yeah. So we see you and we see the notes that you have at the bottom, you know?
Yeah.
Yeah. Of course, it worked when
Can
we
you see it
tried before we start, but
yeah, it's embarrassing. I'm sorry for
yeah.
this, but
Do you want
we
me to
tried.
share it on my side otherwise with
Yeah,
a,
maybe it's easier.
yeah.
Yeah, I stop sharing then.
Yeah. Okay.
Thanks.
So let me put that one here. Already put it on. Where I have it. I'm sorry. Up. Let me refine it again. Yeah, maybe you can just explain quickly what GRC is while I'll just look at your presentation because I know it, but I'm not sure that
Yeah.
everyone is familiar with the
Yeah, for
acronym.
those who are not familiar with the GRC, we are a Directorate General of the European Commission. We are tasked with handling, managing knowledge for policy. So we are a research organization, but we are also a knowledge management organization supporting all the policies of the Commission across the board. I'm particularly working in a unit dealing with water and ocean policies. So our angle is quite specific, but the GRC as such is a Directorate General of the Commission. Particularly, we have been involved in the assessment of how the past directive was implemented and in the analysis of policy options that led eventually to the proposal of the recast directive. That is, of course, not the result of a scientific analysis alone, but rests on a number of assessments and quantitative policy analysis. If we can move to the next slide. I would just start from considerations on what pollution is when we speak about wastewater. Actually, Europe has a long track record of treating wastewater. Many countries have very advanced treatment systems. Some countries are slightly lagging behind, but overall, Europe is moving fast towards full compliance, relatively fast towards full compliance with the old directive. Meanwhile, the old directive was addressing the urgent pollution from wastewater from large agglomerations. There were cities that didn't have a wastewater treatment plant at the time when the directive came into force. So it was a very different situation. Now, after 30 years of implementing the old directive, the directive of 1991, there are still a number of pollution sources that we have to take into account and to address as a challenge for the future. You see this graph that summarizes the situation. Everything is expressed as population equivalents. So the pollutions that would be discharged by one person equivalent in the environment, taking into account that some person equivalents are removed by the different treatment processes and technologies in place in Europe. So you see that there is a large component that is the blue one, representing what is anyway discharged through wastewater treatment plants, and that's quite important. But there is an equivalent amount, or sometimes a larger amount, that is associated with other sources of pollution that are not the wastewater treatment plants compliant with the pre-existing wastewater treatment directive. Uh, Out of them, particularly micropollutants are a large component. Coliforms, pathogens, etc. Phosphorus is quite important, and nitrogen as well, whereas BOD is already treated to a large extent in all wastewater treatment systems. So what is out of the wastewater treatment plants is for now the most important component. If you move to the next slide, just a definition of what stormwater overflows are. This is a narrative in the impact assessment of the new directive that tells what we all know quite well, but just to focus on what's happening in our urban environments. During rainfall events, stormwater overflows and urban runoff represent a sizable remaining source of loads sent to the environment. Click. These emissions are expected to increase due to the combined effect of urbanization and progressive change in the rain regime due to climate change. Most of this pollution takes place during a relatively short period of time, bringing suddenly in the receiving water body a peak of untreated pollutants, including waste and litters from the streets, such as plastics and microplastics. Next. In case of heavy rain, we send directly to the environment part of stormwater overflows and urban runoff without any treatment. Next slide. This is an analysis that we had performed on how many population equivalents correspond to urban runoff, so only rainfalls that runs off urban surfaces, impervious urban surfaces, without passing through the buffering processes of natural soils. And you see that it's quite sizable. If you click, this is the distribution that, of course, corresponds to larger metropolitan areas and higher population density. If you look at the share of runoff in terms of how much percent it corresponds of the treated wastewater load, you see that it all depends on the countries to an extent, but it's quite stable. For BOD, it corresponds to a large component. For nitrogen and phosphorus, it corresponds to a smaller share of what is discharged anyway with a wastewater treatment system. And for total suspended solids, it's much more than what is discharged through the wastewater treatment systems. Next. We have assessed a provisional balance of microplastics in Europe that took into account different pathways through which, let's say, common polymers and tire wear particles, so the consumption of tires, contribute to the pollution of the environment through different pathways: separate sewers, combined sewer overflows, discharges through wastewater treatment plants, and an area where we have a large uncertainty, what ends up in sludge, hence sometimes on agricultural soils, and eventually leaches or can leach to the environment. On that, there is very little evidence available, at least to build upon. But nevertheless, we tried, click please, to assess the relative responsibility of contribution to environmental loads of common microplastics, and you see that combined sewer overflows sometimes have a predominant role, sometimes they are less important depending on the countries and depending on how the combined sewer overflows are managed. So they can be predominant or not compared to the wastewater treatment plant discharges, but sometimes they are a problem. If you click next, when it comes to tire wear particles, not only combined sewer overflows represent an important pathway of loading to the environment, But CSO, combined sewer overflows, and discharge through wastewater treatment plants can be overridden by what comes through runoff. So what initially was considered basically almost as clean water in the old setup of the directive of 1991, that has been now recast with new provisions in the new directive. Click, please. Uh, Mercury is another aspect that is of concern, particularly when thinking under the Water Framework Directive. It's a cause of non-compliance in many cases for several water bodies in several river basins. Combined sewer overflows, according to our estimates that have, of course, an uncertainty, contribute to a sizable share, but urban runoff contributes to a very large share, even though it's not the main one. The main one is still atmospheric direct deposition, but contributes to the pollution of water bodies in some cases in Europe. Next, please. If you click, I have provided you a range of uncertainties that, although the uncertainty is there, there is evidence that it's quite a robust estimate anyway. So you can have a look at the numbers more in detail if you are interested. Uh, so what was the provision of the Urban Wastewater Treatment Directive in the past 30 years? Basically, collecting systems were supposed to collect and bring to the wastewater treatment plant household wastewater, so water that comes from excreta and from waste coming from domestic users. They could be combined with flows coming from rainfall or groundwater, but that was considered to be relatively exceptional, and there was no specific provision on how to handle the occasional overflows that were inevitable because of this combination of rainfall together with more stable discharges, more predictable discharges from households. Member states had the responsibility to decide on measures to limit pollution from stormwater overflows, including basically considering a minimum dilution rate when overflows were expected to happen. That was tantamount to what was foreseen in the old directive. Next slide. The new directive expects to address quite aggressively the remaining sources of pollution that I have highlighted above. So stormwater and urban runoff are supposed to be addressed substantially with homogeneous provisions in the applicable in the whole European Union that correspond to several million population equivalents depending on the contaminants that we are addressing. Next slide, please. Urban wastewater, as you know, means, according to the recast directive, any of the following: domestic wastewater and the mixture of domestic wastewater and non-domestic, urban runoff, and everything together. Urban runoff is precipitation that is collected by combined or separate sewers, so it can be mixed with wastewater or not. And stormwater overflows mean discharge of untreated urban wastewater into receiving water from combined sewers caused by precipitation or system failures. So overflows may happen based on these two prerequisites. Next. Article 5 introduces basically the whole discipline of combined sewer overflows that are supposed to be addressed through integrated urban wastewater management plans for all large agglomerations above 100,000 population equivalents by 2033, so in 8 years' time. And for smaller agglomerations, based on the existence of specific conditions, for all agglomerations between 10,000 and 100,000 population equivalents 6 years later. And these smaller agglomerations need to be identified by member states according to guidelines on the assessment of risks that are being discussed now in the implementation phase of the Urban Wastewater Treatment Directive, but conforming to the principles already cast in the directive. Next slide. For smaller agglomerations, a plan for stormwater overflows is needed when there is a risk for the environment or human health, and when stormwater overflows are identified to be a large component of the load to the environment. There's a threshold of 2% of the annual collected urban wastewater load calculated during dry weather, so assuming that rainfall is not discharging into the environment pollution coming from households or wastewater, domestic wastewater. Relevant points, stormwater overflows should be addressed whenever they prevent the achievement of objectives of the water acquis. Sorry for the typo there. The relevant points in separate sewers have been identified where urban runoff is expected to be polluted in such a way that its discharge can be considered a risk. So that's also another condition where a plan is needed when even simple runoff, so not mixed with domestic wastewater or industrial wastewater, can represent a source of pollution that poses risks. That's included in the directive, even though runoff per se is not considered to be wastewater according to the legislation. Next slide. Next, sorry, Arthur. Okay. These plans are supposed to contain basically an analysis of the situation, including what can be done with the existing infrastructure to mitigate and to control overflows, so to minimize the pollution released to the environment. And an analysis including climate projections and including an estimate of the pollution loads released into receiving waters in case of rainfall through an analysis that should be dynamic. So in some cases it's possible to rely on very good monitoring networks, but most of the times the main approach to that is through a model, a calibrated hydrological hydraulic model of the network of a certain agglomeration. For separate sewers, there's a requirement of including a detailed description of the monitoring requirements at relevant points of separate sewer systems where discharges of urban runoff are expected to be polluted. So basically identifying where there is a risk of pollution and what should be done in order to understand this pollution and characterize this pollution. Next slide, please. Then the plan should lay out objectives for the reduction of pollution, and that is a complex topic. Basically, the plans should achieve that only a small percentage of the annual collected urban wastewater load, calculated in dry weather conditions, is released to the environment. Besides the progressive reduction of releases of microplastics, of plastics in general, to the environment. This small percentage should be less than 2% as an indicative target, and that has to be analyzed and discussed more specifically with reference to the specific situation in each urban water management plan. Next slide, please. The measures to be taken to achieve the objectives need to be described in the plan together with a timeline for the implementation of those measures and a clear identification of the actors involved and their responsibility in the implementation of the integrated urban water management plan. Basically, this is an area where there will be a need to come together, the water operators, the municipality, governments, and urban planning in general, all the actors, urban developers, etc., that have to take into account the objective of minimizing releases to the environment. So adopting measures that are not only in the form of pipes, tanks, pumping stations, and the like, but will mostly be through management of land, of urban land, in order to prevent the release of polluted waters from cities as far as possible. Next slide. When assessing the measures, that is what I was stressing now, the main focus should be on preventive measures, aiming at avoiding the entry of unpolluted rainwaters into collecting systems. Uh, Natural water retention, rainwater harvesting measures aimed at increasing green and blue spaces in urban areas that help reduce the loads to the networks and eventually to the environment. Uh, then, as a second priority, but still before embarking into any new infrastructural development, should be better manage and optimize existing infrastructure. There is scope for improvement in several situations where through for instance, modeling and digitalization of the operation of certain automatization of the operation of certain infrastructure, you can improve the situation considerably, even though it's not addressing the problem to its full extent, probably. And then only when where necessary, adaptation or development of the infrastructure with priority to green and blue infrastructure, of course, but whenever needed, that's also the last resort option that is always available. Where relevant, water reuse shall be considered in the context of the development of these plans. So that's also a possible objective. Next slide. This is a definition that we have. It's a very simple one. The dry weather flow content of an overflow. It's a definition that we have used in the assessment of policy options. Basically, even though rainfall that becomes runoff and is collected in combined sewer overflows is by no means unpolluted, so in some cases it can be highly polluted as well, uh, a practical indicator turns out how to be the content of wastewater that is associated to an overflow, and that can be calculated like this. So it's the ratio of the dry weather discharge to the discharge measured in the combined sewers during a rainfall event. Um, and this could be assumed to be the target. Basically, this content summing up the content during all combined sewer overflow events in 1 year should not be more than 2% of the dry weather flow on 1 year. That is what we were starting from as a possible indicator that, of course, needs to be elaborated upon a little bit more. Next slide. Actually, indicators are somehow rather well correlated when you start setting objectives for the urban water management plans, according at least to the experience that we have put together, and that will be a subject of further investigation in the development of the integrated urban water management plans. There are several possibilities to set practical indicators to manage overflows. For instance, one could look at the duration, overall duration of overflows in 1 year, for instance, expressed in hours of overflow, the ratio of dry weather flow discharged to the environment as a fraction of the total dry weather flow discharged by the agglomeration through the wastewater treatment plant. and the overall volume of combined sewer overflows, so the volume that you materially measure at the overflow point, so with a measurement device or estimated in another way. According to our calculations, all these indicators are relatively well correlated, so we will address the topic in the coming months when we will have to agree with the member states on harmonized ways to develop these integrated urban water management plans and setting indicators. But we expect that the indicators themselves adopted already in several member states or regions will have a possibility to be recalibrated somehow in order to be useful directly for the checking of these objectives. So that's to be discussed further on. For the time being, we have conducted some preliminary assessment of what it takes to reduce combined sewer overflows. Next slide shows, if you can move to the next slide, shows that you can reduce the untreated combined sewer overflow volume considerably through different strategies, starting from the current situation using grey infrastructure to different extents, using the green infrastructure, so greening cities and maximizing the buffering capacities of urban surfaces, combining the two, or providing treatment to combined sewer overflows before they are eventually released to the water bodies downstream. So that could also be an option, of course, if you don't have the possibility to reduce the pollution upstream, you can still implement a treatment system at the point of release and then release the water after cleaning. That is equivalent to removing part of the load, of course, and it's the third priority that we have mentioned, infrastructure with a preference for blue and green infrastructure. Next slide. Okay, in the previous slide, you saw our preliminary estimates of the costs of these systems that are not small. They can be up to what we quantified, up to 200 euro a year or more per person equivalent uh, in the interested agglomerations. But it can be also much less if you adopt a wise blend of measures, and of course, if you leverage the capacity of the networks that we haven't factored in yet. So there can be much less expensive measures that one could find out in specific situations. That is to be understood. But these costs correspond also to benefits. There are some benefits that have been quantified and monetized to an extent. There's a possibility to reduce the temperature of urban areas. That is particularly important, particularly it's one of the benefits of the greening of urban areas. There is a benefit in terms of possibility to save energy through microclimate control. There is a possibility to, of course, reduce runoff besides reducing combined sewer overflows, and so maximizing other benefits, including also the biomass that can be stored in green urban spaces. And so it's a measure to store carbon and other benefits, for instance, associated to biodiversity and in general the livability of urban environments. Click, please. We have quantified some of the benefits in monetary costs, but there are benefits that we didn't quantify and that could be even more important, for instance, in terms of improvement of the urban landscape and the attractiveness also for real estate, for urban properties. That's all to be considered when developing an integrated urban water management plan that will apparently call for um, uh, close collaboration with urban planning at this stage, and that will be essential not only to achieve efficient solutions, but also to minimize the burdens for the water operators, and sharing the budgets as broadly as possible among the various actors interested in the initiative in urban areas. Next slide. The provisions on stormwater overflow management in cities have also side effects that can be very positive. I mention here two important aspects, but there can be more, of course. On energy neutrality, less diluted wastewater, as we expect from some of the measures that will be implemented, will lead to easier to use carbon in the wastewater that could facilitate energy recovery. Micropollutants will also be in itself, so that should be the measures on quaternary treatment that are also part of the provisions of the new directive. Next slide, please. So urban runoff is a problem to address that is further exacerbated by combined sewer overflows. The new directive doesn't set stiff requirements. It aims at triggering a process centered around urban wastewater management plans that requires integrating water management in urban planning to an extent that is much broader than current practice in many urban areas, of course, with a few or many very good exceptions. There is a prominent role of urban greening in addressing these challenges, and there are clear implications for adaptation to climate change and water resilience that this provision of the Urban Wastewater Treatment Directive contributes to prominently. That is it from my side. Thank you, and sorry for spilling over a little on my allocated time, but happy to address questions later.
Yeah, thank you very much, Alberto. As mentioned earlier, I think I see some question already on the chat. I think I will already leave the floor to Hannah directly, so to ensure that all speakers have time, and we'll take the questions after it. So Hannah, you are born and raised in Berlin. You study environmental engineering at the Technical University Berlin. Since then, you have been involved in sustainable resource management projects, with closing local nutrient cycle, recycling greywater, of decentralized management of rainwater. You have worked both in Berlin and abroad in development cooperation and humanitarian aid projects. And since July last year, you have been part of the Berlin Rainwater Agency and support the implementation of the Sponge City Berlin. And your presentation title is Decentralized Stormwater Management in Berlin, Challenge Politics and Participation. So Hannah, the floor is yours.
Okay, thank you very much. I will share my presentation.
Yeah,
Can you see it? Yeah, it's working.
Yeah.
Okay, great. So, thank you for the invitation. And thank you for the very interesting talk that we had before. It was really interesting also for me to hear, but now we are going very specifically to the city of Berlin. So on a very different level, and talking about decentralized stormwater management in Berlin. So I think because we are people from all over, it makes sense to give a short introduction on how the water cycle works in Berlin. So we have like a partially closed water cycle, which means that the raw water gets extracted from the groundwater via wells, and the water which is treated then in the water purification plants, is 60% of it is bank filtrate and 40% is groundwater. The water is then treated to drinking water and gets distributed into the city. It's also important to know that 95% of the raw water is obtained in the urban area. And after the water gets distributed and used inside the city, the wastewater, meaning the black water, but also partially rainwater, will become later through, gets piped via the sewer system to the wastewater treatment plants, which you see being the green dots on the map. And they're located mostly, except one wastewater treatment plant outside of Berlin, where used to be the former wastewater irrigation fields. And the wastewater gets treated there and after discharged into the surface waters. And because of this, it's important to know that the condition, meaning the quality and the quantity of the water bodies in Berlin, is important for its ecology, but also for the provision of drinking water. In Berlin, we face different challenges, meaning one is the quantity. What's important to know that we expect a reduced water inflow, which we can already feel, but it's getting more because of the end of the coal mining until latest 2083. I will try to show you. Can you see my, yes, you can see it. So because like we are in Berlin here, and a lot of, we are very highly dependent on the water coming from the source of the Spree River, which starts here. And for 150 years, we were relying on the water coming from this region and being influenced by this region where a lot of coal mining was done. And so the water was pumped from there into the Spree River and thus being available for the city of Berlin. It's important to know that nowadays it's between 50 and 70% of the water flowing in the Spree is coming from this region. And as the holes will get flooded now, or they start already to flood them, the water we're missing in the Spree River, and as a result, we will have less water coming to Berlin, and also dry periods in the Spree can be expected in the future time. What you can see also on the left side is what is one effect of this is falling water levels, being surface waters, but here as an example is a groundwater level that in the last 60 years on many points where the groundwater gets extracted, the levels are falling. And in some summer times, we sometimes already have the problem of a lack of water, even though we always said Berlin has no problem with water. We are a water-rich city. It's changing now. And additionally, it's also important to say what all cities all over the world, and also not only cities, but also more rural areas are facing the effects of climate change. And by that, increasing heat and evaporation, and also more dry periods and heavy rainfall events. Going into the stormwater management of Berlin, how it's organized, we have combined sewer system and a separate sewer system, what we were talking about before. The separate sewer system is the dark green, which you see more in the outside parts of Berlin, not in the city center. This was started to be built in the 1920s, and there the stormwater and the household wastewater gets collected separately. And the stormwater gets piped to surface waters, and the wastewater from the households to the wastewater treatment plants. And the combined sewer system, as we all know, it's the combination of household wastewater and rainwater, which is collected together. And it's inside the city because it's historically old and was built between 1873 and 1909. And yes, so the water is collected there together. And in the city of Berlin, we have the problem that the surface has got more sealed in the last 150 years since the sewer was built. And the runoff is also increasing. And as we have limited capacities in the wastewater treatment plants where the mixed wastewater is going through, the limitation actually is the biology of the wastewater treatment plants, and it's able to treat only 2 times the dry weather influx, which means for the combined sewer system, only 0.4 liter of rain per square meter and hour, which is nothing. So almost all the time it rains in Berlin, in the combined sewer system results in an overflow into the surface waters. So here we can see on the right, on the up, there's a map of the red dots are the outlets of the combined sewer system. We have around 190 outlet structures. And on the left, you see a photo of an example. Yes, and so always when it almost always when it rains, which is now like between 30 and 60 days a year, the water is released into the surface water. And it's always between 1 and 2 million cubic meter per year, which is a lot. And yeah, this problem will increase, as I said, because of less water being running into the Spree, higher temperatures in the surface waters. So the problem we already face of eutrophication and fish mortality will increase in the future. Berliner Wasserbetriebe, so the Berlin Water Agency, did a stormwater program starting in the 1990s to decrease the amount of overflows and created 300,000 square cubic meter of space underground. But it's important, like this program is ended now, so it was built over 30 years, and the extra space that was created is already consumed by more sealing, climate change, and so on. So compared to 1998, when the program started, there's no difference in overflow. The effects that we see in Berlin is, of course, on the left, you see the sealing structure, so impervious surfaces, and resulting in what I talked about before, the increasing combined sewer system overflows and water degradation, but also urban heat, that in Berlin, we have around 10 degrees difference between the inner parts of the city and the outskirts in summertime, and also flood risks all over the city. So this all means like sometimes having too much water and at the same time having too little water. So we come to the strategy of decentralized rainwater management for what we can call a sponge city. So the idea is to change the water management of Berlin to get closer to the natural one, which means that we reduce the runoffs and instead retain the water, infiltrate it to recharge the groundwater, but also to make it plant available, to evaporate the water from surfaces, from plants to cool the city, but also to utilize the water, for example, for toilet watering the garden or laundry, to substitute drinking water. And about Berlin, it's important to know that in 2016, this was the first time that this was implemented in the coalition agreement of the Berlin city government. And that was written that it's the need to advance the decentralized rainwater management as an effective part of climate change impact adaptation. And a specific measurement, it was written that for new urbanization zones, all should be developed with decentralized stormwater management. And for areas being connected to the combined sewer system, there should be 1% annual disconnection every year of the surfaces which are connected to it, which did not work out because, yeah, it would be 70 hectares per year. And just as a teaser, unfortunately, it was just more political aim. And additionally, there was like a fund which was created, which is 1,000 green roofs program. So especially for the inside part of the city where there's like a lot of competition for space to fund if people do green roofs for higher retaining rainwater there and to evaporate it in the city. And additionally, it was said that to found the Berlin Rainwater Agency, so Berliner Regenwasseragentur, where I'm working, to implement all these strategies, because it has many, it's not only that the ideas are there, it needs to have a combination of stakeholders, of the administration, of politics, of governmental things. So the Berlin Rainwater Agency was founded to implement these things and to do everything that it comes into an implementation. Maybe I don't go to all the details because it's taking too long, but in the next coalition agreement, it was said like the term water sensitive urban development was written down, and also Sponge City was named the first time. And the expansion of the green roof program for green facades and other programs were written down. And in the last coalition agreement in 2023, it was written Berlin must become a sponge city. And yeah, also like more specific things like for the combined sewer system, there should be a feasibility of long-term disconnection of all areas from the combined sewer system. And for funding, that was more broadened for also unsealing and decoupling programs from the combined sewer. At the same time, it's important that also in the Berlin environmental administration, there were some regulations that came out. They are called the BREWA-BE in German, Begrenzung von Regenwassereinleitung bei Bauvorhaben in Berlin, which means that there was the default for construction programs for decentralized rainwater management. They must be ensured through planning precautions from the beginning on. So, and this applies likewise on new building zones and construction projects in built-up areas, and on private and on public land. And in the beginning, it was said that the maximum discharge into the sewer system could be between 2 to 10 liters per second and hectare, depending on which area in the city where you are and which river you are discharging in. And in 2021, this was even tightened, that for the combined sewer system, there was no discharge allowed anymore, not at all. And for the separate sewer system, if you can prove that there's no alternative possible, you can discharge maximum 2 to 10 liters per second at hectare, which means maximum 1 liter per second in practice. Yeah, so we come to like how we do the planning of decentralized stormwater management. So first of all, we always say it's like depends on the necessity and the goal of the measurements. So first of all, talk about the challenges, for example, reducing the runoff due to obligations, or because people want to reduce the runoff themselves because they want to reduce the stormwater fees, for example, and utilize the water themselves. And also to think about goals and added values, which come aside, for example, inside the city to have higher evaporation for cooling and lowering the air pollution, and for the outskirts, reducing, for example, drinking water by replacing it with stormwater. Yes, maybe I don't go to the details. It's like doing initial assessment of feasibility and in the end doing comparison of different alternatives. So I guess all of you know that there are different measurements. So I just give some impressions from Berlin. So either being at the building, being green roofs or facades, also combination with photovoltaic, or on the property, like being at the collection of rainwater or the infiltration in the ground, or in public spaces, or also in cascades, depending on where you are, which surfaces, what you can do. Coming to the task of Berliner Regenwasseragentur. So as I was saying, the task of Berliner Regenwasseragentur in general is to implement the sponge city in Berlin, which means supporting stakeholders to do the transformation into a sponge city. So to convince them to join, to empower them to take their role, and to facilitate the cooperation between them. So we have different services. The first is that we have a free consultancy for people from Berlin, unfortunately only because we are paid by the Berlin government. So if property owners come to us and tell us we are not allowed anymore to discharge our rainwater, what can I do? We have consultancy, so we have a look on the property. So what is the condition of the surface where the water is collected from? Is there the need to infiltrate it? How are the soil conditions? How are the legal conditions? How is it financially? So we have like give a first advice of what might be the possibilities on the respective properties. Additionally, for urban development processes, so when new urban areas are built, we are involved from the beginning on to make sure that the decentralized rainwater management is ensured on the property. Additionally, after our consultancy, depending on how complex it is, we also offer support so we offer the support by on our webpage that we have seed research for specialists, e.g. engineering offices or landscape architects, depending on what the measurements should be. And also we have on our webpage a collection of best practices from Berlin to give inspiration for people. Additionally, we moderate exchanges, and we have every 3 months an online webinar to talk about rainwater management in Berlin, and we always choose topics which are relevant for the city. So this is our team. We are 10 people from Berlin, and we are a team of, like me, environmental engineers, but also urban planners, landscape architects, and geographists. So this is our team. And yes, I think time is okay. So thank you very much for your attention. Yes,
Yeah,
I hope you got some new information.
Yeah, thank you very much, Hannah, for this nice overview of what's happening in Berlin and what's the water situation there. I see we have already some question in the chat for you that we'll take later on, and one in the Q&A function. So if you want to have a look at it already. And now, but not last but not least, then the final presentation for Moritz Gersterding. You are head of research and development at Acco Beton, and you will present us some solutions offered by Acco. So Moritz, the floor is yours.
Thank you very much, Arthur, for a kind introduction. Thank you, Anna. Thank you, Alberto, for the very interesting presentations. I like to wrap it up with the view of the manufacturers on this, putting everything into action that has been discussed. That's what I see as our responsibility. So I will start my presentation and start sharing. Oop. Share screen. So Arthur, let me know.
Yeah, perfect.
My screen can be seen, so you
Yeah.
can see the road and everything. Perfect. Yeah, so we as manufacturer, we define the task that we need to fulfill in order to achieve a water-wise city from the technical point of view under these 4 tiles: collect, clean, hold, and reuse. You could also say drainage, purification of the water, store the water somehow, and then the reuse. It's not in the traditional sense as we're now discussing, and I think the wastewater framework directive also opens it to like direct water reuse from wastewater treatment plants. We need to put it on tiles, so it's reuse, but it's more in the sense of putting the stormwater into usage. I think as Anna already presented on her presentation as well. So not in traditional sense. And these are the main tasks where we need to and see the need to develop products for. And then, see, yeah, we have the, let's say, underlying requirements or goals we want to achieve with these 4 product tasks. So the first one is, of course, the quantity management. This is coming from the traditional drainage. We need to protect people, traffic. It's for safety. We need to deal with floods, but something that has also been mentioned already, and where the focus is shifting, it's also managing with drought. So quantity management is not anymore just getting the water away, but also keeping the water in the cities. And of course, the parameters that are relevant for product design and choosing the right product for the application are then the rain intensity and duration, what kind of retention volume is needed, and then in connection to the quality, also full flow or bypass treatment. And especially, this is something very interesting that Anna mentioned as well, what we, of course, as a company based in Germany, very well aware of, are the requirements of the maximum amount of water you're allowed to discharge. And I think 2 to 10 liters per second hectare, where you're coming from originally, is not a lot of water. So we need to think about how we manage the quantity by retaining it and then releasing it. And of course, interconnected to it is the quality. Where we as a company originally come from our treatment products, it's EN858, oil separators, light liquid separators. So the hydrocarbons back in the days, I would say, was our main target. Now, for several years already, we see the shift to other pollutants like heavy metals, polyaromatic hydrocarbons, or the TSS with tire abrasions and everything which is connected to it, of course, microplastic, and with the other micropollutants attaching to these particles. So really the focus of removing the TSS to achieve the water quality which we need to either use it or then infiltrate the water or discharge into the receiving water bodies. And of course, here the parameters is looking at what kind of pollutants I have. It's the concentration, it's the maximum pollution load. And again, as I said, connected to the quantity we need to in order to choose the right product for the situation on site, see if it's a full flow or bypass treatment. And the relevant point here is also that we don't know what kind of pollution loads are coming. It's all an assessment or mean value of yearly loads and not certain concentrations we often can work with. So a whole different perspective than for other quality measurements and water management. And the last thing we want, of course, achieve is we adapted now the amenity. We want to make our cities more livable. We want to have the green infrastructure. We need to cool our cities. We, in the times of droughts, need to then be able to have the water on site and deliver it to the plants and urban scenery and so on. And I'm actually not sure what the right English word for it. In German, we call it Spannungsdreieck. I would now translate it as the triangle of tension, because it's really difficult to achieve all three at one time. And especially because you have the space and cost constraints. So for the amenity and for green solutions, always the preferable one, but you need a lot of space. And then, of course, we are all aware water quality costs. So the better I treat my water with full flow treatment, the higher the cost. And then the same goes for quantity management. So it's really a decision, in my point of view, where you need to look at each single project of where you draw the line and where you position yourself in this triangle. And also, of course, then choose the according products and, or let's say, solutions, design solutions, and treatment quantity and quality solutions, which you need to fulfill the goals you want for the specific project. Also, we already talked a little bit about legislations. Here, just 4 examples from 4 different countries, or with the European Union, the head of everything. So the wastewater framework directive, we all know it, a really huge step that has been taken. And below that, we have for the German water cessation guidelines as the 138 for the infiltration of groundwater. We have a SATS manual from Great Britain. We have a Polish guideline where I have to excuse my tribe. I tried to learn it, but I will not pronounce it, not to offend anybody. But there again, it's a clear goal of treating the water before discharging it into groundwater or receiving water bodies. However, what I would like to point out from the manufacturer's perspective, these guidelines all define treatment goals and influent concentration or maximum pollution loads, but they don't tell you how to treat the water, and they rarely define any specific testing requirements to actually prove how your product is working. So this might sound a little bit unusual coming from the industry, but I'm very much in favor that we get more regulations and clearer guidelines here. So it's kind of a plea to all involved parties here, authorities and according actors, to work on clear guidelines so all involved actors can compare solutions and actually be able, based on solid results and solid data, to choose the right treatment and management option for their product in order to protect our precious water resources. And of course, everything is then related. I now adapted here our journey to holistic systems, coming from traditional drainage and then moving to water sensitive cities, sponge cities. So the topic what we're talking about and where we come from, we adapted now, let's say, the gray infrastructure. We have traditionally sealed surface. Back in the days, it was made quite simple. You seal the surface, you drain the water somehow, you put it to the sewer network with the consequences of combined sewer overflow. We've seen that in the presentation of Alberto. Anna also mentioned as well, with the negative consequences, with the high pollution loads going into the water. And we want to shift, adapted with the goal of open surfaces. We want to drain with direct discharge to receiving water, direct infiltration, attenuation, to reduce pressure on sewage network, and very importantly, of course, a combination of the above to make the water usable within our cities and actually do something with it, not just get it away, but do something with it. And this has, of course, a consequence on the products or design solution or solutions we need for that, because we need an according stormwater quality and quantity management. From the gray solutions coming, we got basins where you could treatment options in there, pumping stations. We have geocellular crates to hold back the water. We got channels to collect the waters in different materials, moving over in between options like green roofs and walls where you're still supporting, let's say with real infrastructure. And then of course, the real green, blue-green infrastructure like swales, grass channels, rain gardens, and retention soil filters. So what we want to achieve, ideally, I would say looks a little bit like this. We have amenity, we have livability in the city, we have clear water management, you make the water usable within the city, you collect it, you have the open surfaces, you reduce the pressure on the sewer networks. But the problem here is, of course, as I said before, it's space and cost restraints. So often we are not able to implement a project like this, and we then are required to use gray solutions, let's say in my wording now, for manufacture like industrialized solutions. And there I would like to point out one important thing. It is really relevant to think ahead in the early planning stage of what you want to achieve, how much green you can put into the project, and what kind of product solutions you need. Because I draw some sketches in PowerPoint just to illustrate it a little bit. There would be different channel options. So you can just collect the water with the channels and transport it, or you could have like some retention volume already in the channel and move your retention load back or to the beginning with channels and not at the end. Then you would have different treatment options depending on what kind of water quality you need. But also, as I said, as there's no clear product guidelines, this product looks really much different. You have options in the shaft, which is the footprint of few square meters. You have other treatment options achieving the same goal with different setups. So if you do not think about that in the beginning of the project, it makes it really complicated at the end to change something there. And then, of course, at the end, to store the water, you have geocellular crates, you have concrete basins, and again, different requirements for the installation. So this is just my plea at the moment for everybody out there. If you design these projects, think about it in the early beginning, because we often encounter it in our daily practical life as a manufacturer, then advising that at a later stage of the project, it's really difficult to have the full options there. And then if everything comes together, this is something we would like to achieve. Here, this is a project Arco realized in Raalte in the city of Netherlands. There was a clear commitment from the local authorities. All the stakeholders came together at an early stage to discuss what shall be done. And then you have really the closed water cycle. You can collect the water, you treat it, you store it, and then you put it into usage. And here it's even with additional drinking water supply, which is not ideal, but also something you could think about in order to make the greenery work at the top. And a colleague of mine came up with a really nice sentence, and I like to say it here. From our point, let the gray do the heavy work. So if you don't have space to implement everything in green solutions, think about where you can have pre-manufactured product solutions that do the heavy work, and then let the greenery shine on the top, and underground where nobody can see it, the heavy work is done.
Thank you
That's
very
it from my
much.
side.
Thank you very much, Moritz. So thank you for giving this, I call it, say, overview on the water cycle. I would like now to ask everyone to switch on the camera from our speakers, and we'll take some of the questions that we already had during the presentation for you. So if I go in a chronological order, I will say Alberto, the first one will be for you. So we'll combine two directly. So one was, do you also consider water from highways or roads as stormwater? And the other one was more like example based. as in Flanders, Belgium, there's a new directive since October 2023, whereby water from streets and squares directly from the surface without pipeline into a green area in street and square without providing treatment. And what could be basically the articulation between the Urban Wastewater Treatment Directive recast obligation and that, let's say, specific regional requirement. Thank you.
Yeah, thank you. On highways, etc., I think the directive is clear in addressing the fact that runoff per se is not wastewater. So it depends on where you are. You may have other provisions that apply, for instance, when highways affect the quality of waters relevant to the urban to the Water Framework Directive. But in general, they are not a specific target of the provisions of the Urban Wastewater Treatment Directive. This doesn't mean that they should not be considered in an integrated urban water management plan, because if a highway or roads of or infrastructure of whatever type represent a significant pressure in that urban area, so discharges are identified as a significant source of pollution, that could be well addressed in the urban water management plan. On the other question, I think, yeah, I mean, disconnecting surfaces, you've seen also in other presentations, is a frequent and sometimes very effective strategy. If the water from the surfaces from which water is disconnected from the network are relatively clean surfaces, so surfaces where you have limited accumulation of pollutants, it makes sense. Of course, if you disconnect the surface that carries a lot of pollution in itself, for instance, a heavy traffic parking lot, that's more questionable, and you need to look at the specific situation. At present, there is no mandate for a specific legislation of the topic under the European acquis, but I think it's already accommodated in the framework of integrated urban water management plans.
Thank you very much, Alberto. Then, Hannah, we had some question for you. I think a couple on the chat and one on the Q&A function. So I'll take the one first on the chat. How do you calculate retention basin in Berlin, and for which probability of rain? For example, 1 to 5 years or more? And are you also considering the forecast of precipitation intensity, for example, in 2050?
Yeah, like most of the infrastructure is like calculated for the usual rain event, like meaning between 2 and 5 years of rain event. And we use the precipitation intensity of the last years then, but it depends on the sensitivity and the size of the area, because every property owner needs to make sure that they can manage the rainwater on their property, so it doesn't go in the public space or on the neighbor's place, for example. And depending on how high the surface area of where the water comes from, you also need to prove that there is no flooding. And then you need to use like 30 years or 100 years rain event. And this is also for more sensitive parts. For example, for underground, for example, you also need to need more modeling. But the usual infrastructure is calculated with up to 5 years of rain event.
Okay, thank you very much. Let me check, because I think we had some others as well for you, and I had for sure one into the Q&A was actually, do you measure the amount of rainwater that is being infiltrated to the groundwater to ensure that sponge city measures are effective?
No, we don't measure this. And I think it's also important to say that the amount of water that gets infiltrated in the ground, only a little percentage of this is recharging the groundwater, as most of the water that infiltrates in the ground is also going to evaporation again. Yeah, but I don't know how this should be measured, and we don't measure this.
Okay, Thank you very much. Then I think we had some questions for you, Moritz.
Yes.
I'm trying to see. Yeah, how are you ensuring that so separate search system and combined search system have not discharge? Sorry. And are you also implementing some type of control for retaining or redistribution the water across the system? Or was it for? Yeah.
The question is directed to me.
I think so, because according to the time was during your presentation, but
No, I think it was just
yeah,
set to Anna because I was a little bit
to Hannah.
confused
Yeah,
with
okay.
the combined suits.
Yeah, okay. Or for Hannah then.
Wait, I
I
need to,
think.
because I didn't
Yeah,
know
yeah.
it was for me, I need
Yeah.
to read it again. What was
Yeah.
the question? How are you
How you
ensuring
ensuring? Yeah.
there's no discharge? Yeah, it's not insured. I think this is the problem. At least as I understand the question,
Yeah.
it's the problem that from the separate sewer system, it's like the plan is to go to the surface waters, but then of course, depending on how high the pollution is, there needs to be treatment. And from the combined sewer system, there should be no overflow, but it's happening. So we need to try to prevent this.
Yeah, perfect. Thank you very much. And I think now, Moritz, we had some connected, I think, to the last slide that we had, one actually. And the project that sorry, I'm sorry, my chart is always dropping down. I'm losing the one I'm reading. The last slide, the new project, how do you ensure accessibility for maintenance and repair work? I
Yeah.
think that's also, in a way, I think also in a way for Hannah. And how do you manage acceptance on all the, let's say, green infrastructures that you can develop?
Yeah. Maybe first on the direct product related question is the access is classic manhole covers for underground construction. The manhole covers are placed and sized in a way according to the European norms. It's the EN 476. So it's 600 and 800 diameters if you need to go down. For the geocellular grades, it is a 400 millimeter cover because you do not need to go in there, and you can't, but it's possible with monitoring and cleaning equipment to go into the shafts there. And of course, everywhere where you need to get into the system, it's according to the norms. And yeah, standard underground construction design, I would say.
Yeah, thank you. And I think I say also that you mentioned something about drinking water in the project that you presented. Drinking water, or based on your knowledge, I would say drinking water companies interested in.
No, maybe I didn't put clear. It's the other way around. So it's not that we have a drinking water source there, but for some instances when there's not enough rain, we're encountering summers with 2 to 3 months of no rain with the droughts, then we can use drinking water to feed the system. And there are many things coming together there, so that people do not use trucks to water the plants. So, if you know the cities in Europe, it's happening a lot of times. So this is something that we can use with the system as well.
Okay. And I think one that was actually also for you, but I think Anna can be also interested for you, is when you do, let's say, a business case or project in a definition phase, how are ecological and social value taken into account and not only just the cost of the project? Where, like, is it already, I assume the question is also, is it for you taken into account? And if yes, where do you put the cursor on what's more, in a way, important than the other? So I don't know.
Yeah, because we don't do business concepts, because we are not selling anything. We're just giving advice on what we think might be useful. And so I don't really know how to answer this question. I think it's important. I mean, we're, for example, one example now where we the first time really think about considering to do also ecobalance, like ecological balance, to calculate it, is for if we only, because we have, for example, one project where the water from a big roof is collected to store it in a tank that it can be used for watering a park, which is next to the building. And so we only have like a half day of half year of the use, and it's not like the full year can be used. So and so we want to also have a measurement how much energy is done for the concrete, for example. So this was also like the first time we were like, okay, it's like not a typical project where it's just about infiltration in the ground, greening roofs, you know, like keeping the water where it falls, but it's also meaning we need gray infrastructure. And there we also need to think about how much energy is consumed for building concrete storage.
Yeah. Thank you, Hannah.
Arthur, if I may, I did a little mistake during the webinar. I thought I was replying to everyone, but I just was replying to our small group. There was a question of the definition of stormwater where Alberto already answered. And I think it's a kind of interesting view from the German side. We have the German water ordinance, and under paragraph 54, all rainwater that hits sealed surfaces and is collected is defined as wastewater with the according consequences of it. And I think like in the international definition of stormwater, it's kind of comparable. That you at least need to make an active decision how the water quality is after you discharge it or before you discharge it.
Thank you very much. So thank you very much, Alberto. So presentation of the new Urban Wastewater Treatment Directive recast and its point on stormwater and overflow and rainwater management. I will, I think, in a future come back to you for some question and clarification needed about the integrated urban wastewater management plans that are new requirements, because based on some internal survey with our member, we have a couple of questions on how is it, what does it mean basically, what should go into it and everything. So I also wanted to ask you quickly if you are aware of some, let's say, activities that will be done, type of the webinars that the GRC can do about water reuse to explain it a bit more, or are you more waiting for any delegated and implementing act on it?
On this, I would just mention that there are provisions in the directive for the Commission to make implementing acts. We are actively involved in that, so we will be part of the conversation for the next few months, and for sure there will be ample opportunities to discuss and come up with something that is practical and effective, because actually the challenges ahead are large and important, and we have to be compact in that as a European water system.
Yeah, thank you very much. Thank you, Anna, as well, for the really good overview of what's going on in Berlin and the situation. Really interesting. I hope we can stay in touch and keep learning. Moritz, thank you for the presentation of overview from ARCO and also for being a sponsor of this webinar. If you allow me, I have few slides before we are done. So I will share my screen. So just quickly, for everyone again, so thank you for those 3 speakers. Thank you for everyone that registered and joined today. You will receive all presentation, and there will be a recording on the EWA YouTube channel, as mentioned earlier. Quickly on our upcoming events, we have another free webinar about the revised Urban Wastewater Treatment Directive Insight and Q&A with one speaker from DG Environment from the European Commission. And we have end of May our spring conference together with our Norwegian national member in Oslo, shaping the future of water management and in Europe, increasing the value of water through the revised Urban Wastewater Treatment Directive. So I think you can see that at least for EWA, it's a topic that's really keeping us busy at the moment, all that revising. And if you want to know more, you can, of course, visit our website, our social medias, the YouTube channel. You can also register to the newsletter. And if I remember correctly, at the end of when I will stop the webinar, you will have a quick survey. If you can take 2 minutes to just provide your feedback, that will help us to, let's say, tailor the offer that we can do in the future. So once again, thank you very much for everyone joining today's. We are 4 minutes in advance, which is always good. So thank you very much again for your time and participation. I hope to see you soon, and thank you. Have a good day.
Thank you to Arthur for the organization. Thank you, Anna. Thank you, Alberto. Have a good day. Bye-bye.
Thank you. Bye.
You too. Bye.
Thanks everyone. Bye bye. Thanks. Have a good day.
Bye.